Well, good afternoon and welcome to today's discussion on the art of the possible when combining satellite connectivity with IoT. My name is Rory Ashley. I am part of the ground control channel team. So my focus typically is around helping businesses do more for their customers, leveraging the power of satellites. I am going to be leading the discussion today, but I will be ably supported by Matthew Ellison, who's one of our solutions architects. Say hello, Matthew.
Hi, everybody.
So Matthew has a great degree of technical knowledge, whereas my focus is more typically on the business side. So today, hopefully, we can give you both avenues of the justification for combining satellites and IoT and doing some very innovative things for your customers. So we are going to run through today in roughly 3 parts. The first will be a discussion of satellite and IoT as a sector. We'll then move on to zooming in on individual use cases or case studies to allow you to maybe get some inspiration for the work that you're doing with your customers. And then at the very end, we'll take a look at some of the insight that we've got in terms of the questions that we get when we talk to the customers and partners of ground control. And finally, we will answer any questions that come in from you guys. Let's start off then with a broad overview of satellite and IoT as a sector. And the real reason that satellite has gained such a prominence in the world of IoT is because of this huge upswing in connected devices. Today, everything, be it a toaster, be it a tractor, everything needs to be connected to the internet because everything creates data, and data is, as it is so often said, the new oil. You can do a lot of things with data. So what this means now is that there is a huge push towards the use of connected devices in all sorts of settings. So we've got a couple of charts on the screen that really demonstrate this growth. So the first is taken in 2018. It was looking at the total number of connected devices globally, split across IoT and non-IoT. You can see that there are just under about 18 billion connected devices in the world in 2018. This was projected for about a 10% increase year on year, so that by 2025, between non-IoT and IoT connected devices, they're going to be close to 35 billion devices. That was taken obviously before the coronavirus pandemic. What we look at on the right-hand side is a graph taken in 2020, and this is looking at the number of only IoT connected devices. In 2020, there were more IoT devices than there were entirely connected devices globally, regardless of if they're IoT or not IoT. Number of IoT devices in the market is huge compared to what it was only 2 years ago. And it is projected to increase over 100% over the next 5 years. So that by 2025, there's looking to be more IoT connected devices than there were projected to just be connected devices in the world previously before the COVID pandemic. And Matthew, I think you might have some insight into why that big change in projections in terms of the growth of connected devices has occurred in the last couple of years.
I think it's just people have realised the value of data and the efficiencies that are created by collecting data and analysing it, or artificial intelligence as well, as if you like. The COVID side of things has sped up digitisation by a calculated 6 years. So we're now at a position where we would expect it to have been in 2027.
Exactly that. And I think you really see the case that when you can't send a person to collect some data, that causes organizations to start to think a little bit more about the ways that they can leverage technology. And I think that's been behind this growth of connected devices. So there are more connected devices than ever before. Business is more global than ever before. And this has led to connectivity challenges that only satellite can solve. We've got a graph here on the right that talks about the level of connectivity in different settings. So globally, you've got about 15% coverage from cellular. If you exclude the oceans, you start to see it's about 50%. But of course, when you look at satellite connectivity, you're coming up on 100%. Satellite provides total global coverage, and that is to the benefit of many, many different types of IoT implementations. You're seeing a particular swing towards the extraction of data from areas that it never has been accessible before. And we'll drill down into what the implications of that are when we look at some of the use cases for satellite and IoT But the key thing I think here is to look at this coverage that satellite provides and think about how that can impact the value created by IoT, being able to put the sensor in the right place, not where it can get connectivity on a cellular network. There's a big difference. The other thing that really has defined the rise of IoT backed by satellite connectivity is the cost factor. Historically, satellite has been seen to be hugely expensive, but this has really changed in the last 5 to 10 years, particularly marked by the entry to the satellite supplier market of a number of challenger organizations, suppliers, thinking about Elon Musk, Starlink, amongst others. And as is always the case, when a market, more operators enter a market, that brings the average cost down. And a really interesting fact about, or the impact this has had on the satellite space, is that our supply of satellite connectivity was run by a small number of large organizations, things like Inmarsat and Iridium. These players are still very active in the market, but they are responding and being encouraged to innovate by the entry of these new players. So what we're seeing now is a satellite market with a large number of providers, some of whom are very new, some of whom have a great deal of heritage, but all of whom are competing, which brings down price, and all of whom are innovating. So you've not only got lower overall costs, but more options that are that allow you to pick the flavor of satellite connectivity that is right for your application. And talking about these innovations in the bigger brands, there's an example that we often point to with Inmarsat and the launch of something called Orchestra, which maybe Matthew, you can say a few words on.
So Inmarsat have traditionally been a geostationary satellite provider, which gives a reliable connection, but you're looking at a directional antenna pointed at their satellites located over the equator. But they've recognized the business model for the low Earth orbits. And so they're going to launch a service with low Earth orbit satellites, and they called it Orchestra, which is going to give them greater strength in the market because they can offer both solutions. Just quickly on this, with Iridium seeing double-digit growth on their IoT offerings with the short burst data. So it's now making up about 25% of their annual income is coming from IoT devices. So it is a huge growing market.
Absolutely. And I think the quote to the right here on the slide really says it all in terms of this desire to find the perfect telecom solution for the communication of data, looking for this holy grail. And I think the proliferation of options means that customers have more choice than ever before to find the satellite solution that's right for them. And that comes very much down to that's what allows satellite to become so much more competitive. IoT device count has hugely increased. The global coverage of satellite enabling this, and of course then the lower cost, meaning that for the first time data that was once out of reach is within reach and can be used. And that is not going to be a one-size-fits-all type of growth. So clearly there are some areas and industries that is always going to be dominated by other forms of connectivity other than satellite. But there are some industries and verticals that are really, really suited to this new satellite 2.0, this growth of satellite, and they fall broadly into two categories. One is industries that are operating in areas where there is no other form of connectivity. So you start to look at things like maritime, out in the ocean, every ship has the potential to be an IoT constellation. A fleet of ships becomes a huge IoT network, a lot of which operates completely outside of terrestrial connectivity. Satellite has huge value add there, similar to things like oil and gas or in mining. So you have this one side of the growth of IoT driven by satellite, which is this area where there is no other connectivity. The other side, equally interesting, is on the fringes, where you have devices that are mobile, they're moving, and they are moving in and out of other coverage. So you have satellite acting as a backup to other forms of connectivity and allowing you to maintain that continuous golden thread of data, regardless of where this device is. And of course, that always on nature and the robust systems that are provided by satellite means that even the value of data received via other connectivity is increased when you know that satellite is always there to back it up. And we'll see that very shortly when we start to talk about some of these use cases. So I suppose, Matthew, any final comments just on the market for satellite IoT before we dive into use cases?
It is the old adage, isn't it? Work smarter, not harder. And obviously with margins and such big operations, small margins, there's huge differences to profit and loss. And the oil and gas industry is certainly seeing that now, where they're really being able to do what they wanted to do because the margins and the profits were there. But now the margins are so tight and such small difference between profit and loss, they really need to collect this data to drive what they're doing and be aware of, you know, where the costs are and where the savings are. So it's a big difference, big change.
Absolutely. And I think it's, you know, when you talk about the scale of some of these things, a lot of the big areas where there is no connectivity lend themselves to huge operations where that marginal gains are really important. So with that in mind, you know, the big changes in the satellite industry, more connected devices, coverage, 100% coverage allows you to do more with these devices, and the commercial changes allow you to do that at a rate that is affordable. Let's look at how that manifests itself in particular use cases, in particular industries. I'm going to sort of take a look at some of the problem statements here that we as ground control see when we are working with customers and partners. And I'll ask Matthew to talk around them a little bit and explain not only the value of IoT, but clearly where the security and the availability of satellite adds particular value. The first one of these that we'll take a look at as a case study is disaster recovery. So what does IoT in a disaster recovery context look like? Well, it can be really varied. You clearly have the ability to monitor the situation in which disasters occur, be that before they happen or after. You've got the man-mounted or person-mounted devices on the people that are responding to these disasters, and then you have connected machines, connected vehicles that are also responding. So all of these items are transmitting data. A lot of the time, they're operating in areas where there is no other connectivity. But I think the thing that is really interesting to note is how a combination of different sensors and different IoT networks can combine to do really interesting things that require that 100% connectivity. Isn't that right, Matthew?
Yeah, it's certainly interesting looking at this, the mitigation of the early warning systems. Generally, you're needing 3 different parameters to come together to form your wildfire or whatever. So it may be the weather, you're monitoring the weather, it may be the conditions on the ground, how dry is tinder dry in the combustible material, or is there fire in the area? Those 3 things come together to cause your wildfire. So if you've got 2 of them, but not the 3rd, there may not be the issues that you're concerned with. And then also on top of that, you need to know where your assets are. So being able to track staff and machinery, helicopters, whatever, to focus your response to the issue that you're trying to deal with saves time and saves money.
Absolutely. And I think this is something that you'll see we come to again and again really here is this: the availability of data allows you to make decisions about how you allocate limited resources in a way that maximizes their impact. And of course, you know, we've seen a summer of floods and fires globally. That really is a use case that's really top of mind. Moving away from this very action-packed use case and problem statement, we can look at something which certainly is probably very familiar to a lot of people on this webinar, and that's the concept of IoT asset management and asset tracking. That this is, again, you know, you're looking at lots of units, each being tracked. Historically, this was, where is my assets? Where are my devices globally? Using satellite, you might be able to track it in the middle of the ocean or the middle of the desert, not just when they were in range of other terrestrial connectivity sources. But I think what's really, really interesting looking at this in the context of the new world of satellite that we've just been discussing is that you can actually really do a whole lot more than just track the assets that you're working with. We've got down here on the slide an example of a self-powered IoT system over satellite. Matthew, could you talk a little bit about you know, what that transition from the really traditional asset tracking to the more active asset control has looked like?
So if you just look at this application here, I mean, the rain falling from the sky is what you're monitoring really, but once it falls and it comes into the channels and the streams and the rivers, it becomes an asset in terms of hydroelectric power generation or irrigation management. So that becomes your asset, and the asset has value to you. So you want to know how much there is, where it is, and when it's going to be of use to you, if you do need it. So that's this particular application here. But if you're talking about other assets and traditional tracking, you're tracking a container or a vehicle, you know where it is, but then you've got no idea of what's going on. And then you move to the monitoring scenario where you're looking at is the engine running, what's the fuel tank level, you're knowing a lot more, is it being driven safely, and then you're onto the control side of, actually we can slow the vehicle down, or we can change the engine's revs or whatever to make it run more efficiently. So and then you start getting into automation. So the data is the beginning of that journey. Being able to capture the data and deliver it reliably from wherever is the beginning of that journey.
Yeah, reliably and in real time, of course, because it's no use knowing that the lorry was going far too fast once it,
it adds value to the data. The quicker you can get the data, the greater value it is.
Absolutely. And I think a really good example actually here is talking about, as we were just doing there, this concept of telematics in the transport industry. So you have this concept of, you've got a vehicle moving from A to B, you might be able to get cell phone signal at points A and B, but in between, when you're traveling between population centers, there's typically none of that connectivity. And the value of being able to use satellite in order to engage with that phase of that transport vehicle's journey is huge. We've got on the right here a little graph just talking about some of the reported benefits when real-time telematics were implemented across a number of transport networks. And it's quite clear that the benefits that's driving above and beyond knowing where your assets are, you can read that yourselves. But I think the other thing is just around what the transport telematic system might look like. This isn't just sensors on the trains or sensors on the cars. This can be sensors on the roads, or this can be acoustic sensors nearby. The power of satellite IoT is that you don't have to be controlled in terms of where you put your devices by where the signal is. You put the correct device in the correct place, and you don't have to worry about whether it's going to gather data. And again, we'll talk about it more and more, that the value of the data, not only is getting the data real time a great value, the other thing that's really important is getting the data from the right place. There's no sense, dropping a probe somewhere that's not measuring what it's designed to measure. It's a waste of money. Any comments there on your experience, Matthew, regarding the transport side of asset tracking?
It was also looking at the value of this data for particularly where machinery are on hire. The person who owns the asset, who's hired it out, knows what condition it's going to come back in, because he knows how long it's been running for. Say with pumps, quite often people, or even lorries, they'll spec the higher or bigger lorry than they actually need for the job. So there's a good relationship to be built there by helping your customer as a hire business. You can help your customer select the most appropriate product for the job, and make sure it's being looked after and run efficiently. The other side of this with satellite is you're not relying on other people. You're not relying on Wi-Fi or other local cellular networks to get the data back. So all the data will come back through a satellite connection without any terrestrial input and reliability.
Brilliant. Okay. Moving on from there, just so that we can get this full breadth, moving away from the tracking of things that people have built to the things that are out there in nature. So there are some really specific and valuable applications of specifically satellite IoT in the field of environmental protection. So you think about, we're talking about the two different threads that you see in where satellite IoT is really growing. One is in areas where there's no signal, and one is in areas where there is intermittent signal. Well, here, of course, when you're tracking animals in the wild, it's a situation where there is absolutely no other connectivity options. So using satellite in IoT for the tracking of animals, or for the building of broader IoT solutions that keep track of animals, as in the case of Instant Detect, which is a ground control partner, where they have built up a network of different devices that allow us poachers to be deterred. These are sort of examples where this just physically wouldn't be possible with people, because they don't have the ability to cover the ground, nor would it be possible with any other connectivity type, because there simply isn't them. And again, to go to Matthew's point about the value of the harder the data is to get, the more valuable it is. this fact data is therefore priceless because it's impossible to get any other way. Looking then, moving on to smart metering. So smart meters are, I won't explain the concept of smart meters, but the value they create is huge, both for customers and for suppliers, and certainly from an environmental standpoint. Enabling you to balance the load across your entire customer community is really, really important, leveraging that edge processing capacity. However, when research looking into this value of these smart meters pulled up some quite interesting statistics that as we can see on the graph on the right, what you're looking at is the percentage of households that don't have a landline connectivity, i.e. the percentage of households where smart meters just don't work. So, you can have, it's a good example or a good illustration of the fact that you can have the best sensor, the best device in the world, but if you put it somewhere that it can't connect, it has no value. So then clearly what you can't do is move it to somewhere where you can get another connection, because the houses are where they are. Much like the animals, they're where they are, you can't really move them. So what you need to be able to do is to be able to get in touch and clearly to transmit that data in a secure manner as well, and not be reliant on anybody else or any other organization to get that data back to you and allow you to make, again, those data-driven decisions. From there, we'll move on to the final example we're going to look at today, which is smart farming. What does smart farming IoT look like? Well, again, it can come in many forms. All of, this is looking at the vehicles. This is looking at sensors. This is looking at tracking of the animals or the people working on the farms. Bearing all this in mind, and bearing in mind that a lot of, typically you wouldn't be able to have these sensors or any other devices active, connected, due to the locations of so many of these farms. What are the sorts of things that you can actually then achieve, Matthew?
It's this usual knowledge is power, isn't it, when it comes to understanding what you're doing? Farming is very weather dependent. So weather drives disease, it drives insect life cycles, it drives crop maturity. So the basic ones are understanding weather and soil moisture conditions just so you can optimize your inputs, because again, margins are very close and tight, and it's a global market. So very small percentage points increase in yield or reduction in input costs has a massive impact on your farming operations. It's just clearly, a return on your investment in that, collecting that data and then being able to action yourself on the data. A lot of times you'll see farmers collect data but are unable to act on that data. So it highlights the fact that they need to improve their investment in being able to respond to things, as well as just optimizing their inputs. So increasing yields. Soil moisture is a massive area globally. Water demand for water for human population, urbanization, and agriculture and hydroelectric power, a massive strain on and needs better management and more efficient use of water and irrigation, just as an example. And then your machinery costs, optimization, looking after your staff welfare with reducing fatigue and helping them do their job better. It's just so many different applications.
Almost all of this isn't possible on a lot of farms without using satellite because of where they're located by definition. So that's a whistle-stop tour through some of the ways that satellite and IoT can work together and add value in particular use cases or particular industries. Let's now get even more specific and center in on some of the questions that we at Ground Control hear when we work with our partners and customers to do innovative and interesting things using satellite connectivity. So again, I'm going to shoot these over to Matthew, be the voice of all of you attendees, and we'll let him come back to us with some of these responses, and we'll pick up any that we didn't get to at the end. The first one, of course, is, and we addressed it a bit earlier, satellite is historically seen to be prohibitively expensive, but that's certainly not the case anymore for a number of reasons. Isn't that right?
Certainly the realization is that satellite is no longer just for places where you can't get connection. You've also got to understand the value of the data, the resilience, and how that data is collected is also important for criticality. We just need to look at the value of the data before we make a decision. As it points out here, we can optimize data transmission, so we focus in on the key data values and report by exception rather than constantly sending over large volumes of data that have no real use because they're the same as the previous step. And edge computing, and we saw an example where we're monitoring water levels, where you can decide to increase your frequency of transmission or only send alarms from site when something changes, the status changes, that becomes of interest to you as you collect their data. Okay,
and another linked question as to what you were saying before is, how secure is satellite, given that there are multiple people all feeding into a limited number of satellites up in the sky?
Certainly the capacity is there to deal with the data, and the satellite operators have got the capacity to change and manipulate the satellites to handle increasing volumes of data. Inmarsat and Iridium's just upgraded their network, and Inmarsat are busy upgrading theirs to increase capacity in key areas. The data goes from your satellite modem up to the satellite and down to a ground station, and it's backhauled from there. So it's secure and very, well, almost impossible to get to while it's in the sky, and it can be encrypted as well. The backhaul, you can have various levels of secure backhaul of the data from the ground station to your premises.
Absolutely. So, I mean, certainly, yeah, it's in almost all cases, it's as secure, if not more, than some of the more the connectivity types that those on this course might be familiar with. So that's really interesting. Similarly and related, talking about the hardware, is that a component of the system that's at risk? Certainly, satellite dishes, sticking out, are they vulnerable to their surroundings?
They're getting smaller and smaller, so they're not so conspicuous and exposed to extreme weather events, I guess. People like Cobham have been built a military company, so they build military spec devices anyway, and they use that knowledge to build very resilient and robust terminals. Long mean time to failures is massive. Just discrete patch antennas for Iridium with the omnidirectional antennas. Put your hardware inside the building or into an enclosure and mount the antenna in a suitable location. So modems are getting smaller and smaller, and power requirements are becoming more efficient. So, and design and quality are ever increasing. It's no longer a traditional Yagi type TV antenna pointing up into the sky. You've got some quite discrete and small.
And as a small antenna is protected from extreme natural disasters and such, they're also obviously protected from those that might want to knock it off for a joke, vandal proof as well. And speaking of those interruptions, then is weather an issue? Certainly, one would wonder whether if there's something between the satellite and the ground station, is that going to cause more of an issue than with terrestrial-based connectivity?
So there are different frequencies used in satellite communication. I mean, the most resilient is the L band. Historically, weather has had an impact on some of the other frequencies, but modern technologies have been able to deal with this. But coming back to the L band as being the most resilient frequency for rainfall impacts on, they call it rain fade effectively with other bands, but L band's the most resilient.
And I think what you're really highlighting there, which no doubt is starting to come through for our viewers, is that there are many different flavors of satellite depending on your requirements, and picking the right type of satellite connectivity is what is going to enable you to best navigate and get most of the benefits. Moving about the, we've spoken a lot about the value of data that comes from places that are hard to reach, or impossible even. That clearly then means that these devices have to be self-sufficient. So what is the impact of power requirement on how satellite connectivity can be implemented in IoT?
So looking at the physics side of it, the geostationary satellites are much further out into space compared to the low Earth orbit satellites. So more energy is required, but the other side of that is because you're using a directional antenna, the power is more focused. So all IoT devices will really run on battery or at least solar power. The Iridium side of things is more suited to battery, but you can run a BGAN terminal on a battery for quite a significant period of time if you're prepared to set it up and look at when you need to send the data and how much data you need to send. So it's a case of balancing power against data transmission.
Absolutely. And again, you think about the value of providing that power versus the value of the data you're going to get back. The calculation comes out very positive in most cases. Moving on then to questions of how these devices can actually be operated. So in terms of ensuring how that they're going to stay working and continue to stay connected, do I need to be out in my garden pointing my satellite antennas in order for them to work?
So traditionally, geostationary satellites, you'd have needed some sort of pointing directional antenna. The Cobham units and the Hughes BGAN terminals provide audio and a visual guide for pointing the antennas to give you optimum signal strength. They also, with user interfaces as well, now you get a signal strength. So it's very straightforward. Iridium and all the low Earth orbit satellite networks, you just want as much sky as you can see as the satellites are moving. There may be to the north of you, there may be the next one maybe to the east or the west. So because they're constantly moving, they'll be in different parts of the sky, but you may have 2 or 3 satellites covering where you are from different directions. Whereas as long as you've got, with a geostationary satellite, as long as you've got that signal and the antenna pointed in the direction, you're not going to lose that connection unless something moves in front of the terminal.
Absolutely. And I think the big thing that you very often see at this point is omnidirectional antennas, either because they are catching or transmitting to satellites that are moving all over the sky, or because they have internal mechanisms that allow them to self-point. So it's really not much of an issue these days, as we're familiar with.
So there's also the Cobham have got an electronically steered BGAN terminal that's for the Inmarsat network. So it's got a number of smaller antennas within it, and depending on which way the terminal's pointing, if it's put on a ship or on a truck or a tractor, it's still going to give you connectivity because it's electronically, there's no moving parts, so it's looking at which antenna's got the best signal strength, and it can travel on a vehicle up to 120 kilometers an hour and still get a very good signal.
And then looking at actually, if somebody on this call wanted to look at how satellite could add some value for their customers in terms of getting satellite hardware installed, is that a complicated process?
The short answer is no. It's just a case of, a lot of satellite equipment's sitting on the shelf in stock, waiting to go. You just got to decide how much data you're moving, how frequently you want to move it. That'll probably dictate what type of satellite solution you choose. You can install it yourself probably, or fix it to your machinery or whatever asset you want to track. And then connect the sensors into it. Either a lot of them now take serial connections directly into them, or whether you want a little logger there to show you storing and forwarding data, or a bit of processing power just to send off the critical information.
And finally, perhaps most importantly of all of this, is we're talking about high value data. Is it going to get there? Can I be sure of it?
Yeah, a lot of it is push data on receipt, and then there's data can be polled from site, so you know that you're requesting the data from the outstation or the logger that's connected to the satellite modem. The connectivity there, you can see 99.9 uptime on the Inmarsat network, so the availability is pretty much there, and secure data backhaul. We can see data that's there. You can look at all the diagnostics to make sure signal strengths are good, and reliability and uptime is all part of modern day data communications.
I think the few key takeaways I would suggest from the session today, certainly that cellular is very much the box in which a lot of people think inside, and we really want to encourage organizations to think about what would be possible using satellite connectivity. So thinking very much about what would be possible if you could gather data from anywhere, what would be possible whether all of your data gathering was totally secure, whether it's not, as is the case in satellite, where it's not reliant on any other systems. And typically the last thing to go down in any system is going to be the satellite comms, because they're so robust. So there is a huge number of new and interesting places that satellite technology can enable IoT to go. And this is sort of backed up by a huge number of different satellite communication services that you can use. We'll break it down into 3 pyramids here, just in terms of the types of data you might use. If you're sending bytes of data per transmission and you're doing it every hour or so, there are things like the Iridium SBD, short burst data network. You've got looking then if you're sending kilobytes of data, sending information every few minutes, starting to look more towards industrial IoT and these sorts of use cases. There are things like the BGAN system that Matthew's been mentioning from Inmarsat, or the Certus system from Iridium. And there is even satellite solutions for when you start to look at transmitting megabytes and really regular or potentially constant connectivity via VSAT and SCADA systems by TSAT that are that more traditional satellite antenna on the roof. So the spectrum of technology that's available here is very broad. And I think that's really one of the things that we as ground control pride ourselves on, is having an offering that covers that entire spectrum and being able to work with companies to help them identify which individual piece of this technology is really right for them and the things they want to do with their customers. And clearly, if you want to talk about that with us as a result of this webinar, then please do get in touch. You're also going to get the slides after the session as well, along with an ebook based with some of the learnings that we've been talking through today. So as we said, ground control, we've got you covered. If you want to be delivering innovation with satellite for your customers, then that's absolutely what we're here to support you on. Having had a look at the FAQs, it looks like we have covered in our frequently asked questions the Q&As that have come in. So I think we will take this opportunity to thank you all for attending, to thank Matthew Ellison for joining me and providing some of that on the ground experience to back up some of these topics that we've been talking through. And so say that we look forward to hearing more from all those on this webinar very soon, and working with you to do interesting and exciting things with satellite connectivity in the realm of IoT. Thank you very much. Bye-bye.
Thank you.